My name is Lester Martin, and obviously you heard the topic once or twice already. We had a little kind of pre-meeting in the back of the room. How long are you going to be, Lester? How long do you need? So I was asked to keep it about an hour so everyone can go home and see their family that they're escaping from, so I'm going to do that. What it will mean is, most likely, as I thought about how to shave a little time off, there was the very last demo at the end. I'm going to stop the presentation at that point. The folks here are actually recording this, they're going to put it together, but I did put a little YouTube video when I practiced this last week that has that full demo as well. So be glad to talk about it afterwards with anyone. I will add a comment to the meetup site with the location of the slides and my version of the movie, and then shortly after a more professional grade presentation will be showing up too. So I'll wait for that one for sure. So who knows a little bit about Apache Storm already? That's good, because if you're an expert, this is not the talk. I don't have my expert talk on. I'll be glad to answer Q&A. Perfect. So connection before content, again, Lester Martin. There I am with my braces. I got them off. You should, if you want to humble yourself, you should get braces when you're about 45 years old. It's really good. It makes you feel really interesting. But I'm 49.0, so I'm working on 49.1 right now. I'm going to stay the 49 the rest of my life. I work at Hortonworks. I live here in Atlanta. I travel a lot, as we were talking about in the background, and there's some other contact information. At Hortonworks, I did consulting for a while, then I used to train a long time ago, and I wanted to train again. So for my sins, they're letting me train right now, which has been a lot of fun. So the agenda that I'm going to shoot for 1 hour, sans this last little bit. I'm going to prep this for you and get your appetite hopefully wet. We'll stop the conversation at that point. And then, like I said, I'll make sure you have that video. And even wants to hang around, we'll go to the pub and we'll do it together there if you'd like to do it. So there is going to be a live demo. I've got an hour to talk about what Apache Storm is and do a demo. So don't expect we're going to solve world hunger. We're going to do something simple. For those that have done anything in kind of the big data space, the hello world's always this word count thing. And if word count's something new, I'll explain it when we get there. All right, so jumping on in. What is Storm? Well, you always have to give the history slide. So I'll just kind of throw it on the screen kind of quickly there. What's interesting about Apache Storm, it's not brand new. When I say it's not brand new, it's not 20 years old or anything like that, but it didn't show up last year. It's been out there for a little while. And it kind of sometimes gets associated with things like Apache Hadoop, even though I would say they're two different projects that solve different problems. They complement each other very nicely. But it's been around for a number of years. Not quite as old as Hadoop itself, but it's been out there and actually became an Apache project back in 2013. And a lot of folks are using it. You can go to the powered by page, and get it straight from the horse's mouth about who, when, where, all that good stuff. All right, so what is Storm? Storm is streaming. And what do I mean by streaming? I think it'd be fair to say, some people say real-time processing, and that phrase real-time means everything to the world. So streaming here is, event-level operations. It could be a log message, it could be a cell phone geolocation blurb, it could be a stock trade, it could be just about anything. And we're really talking about a framework that lets us consume those events, hopefully at massive, massive scale, at blazing speed as well. So it's fast. Some old metrics are out there with some small Dell machines a couple years ago. Those numbers are always what they are. You got to run your application through your hardware, through your process and see what the heck happens. But I would say that no one's going to disagree that Storm is fast. I didn't put mature, but Storm is mature as well. Scalable, you saw that Yahoo uses about 3,500 processes computers. Now I don't know if they have them in one Storm cluster or that's a couple different Storm clusters. The biggest I've seen in my professional career, personally with my hands on, are measured, more like 25 or 30 machines. But you can do a lot with 25 or 30 machines with, 256 gig of RAM and so on. And just like any of these systems that are clustered, it's going to blow up, something's going to break, we need to deal with that. So always fault tolerant, of course. But what's really, kind of tricky in this whole stream processing space is this unicorn called exactly once processing. How can I guarantee you one event process one time and not, that's difficult. What's easy is at least once or at most once. Those sound scary if you have an accounting background, but they are hard to do in streaming frameworks. So Storm is these great things. If you bear with me, that's trying to be Lester's pictorial representation of the Lambda architecture, the old, the batch layer, the speed layer, and the serving layer. If you've never heard those terms, don't worry about it. Just know that it fits in there nicely. If you have heard those terms, you can replace a lot of technologies to fit your Lambda architecture. And definitely down in the serving tier, this could be a lot of things. It could be Hadoop, it could be HBase, it could be Hive, it could be databases, it could be homegrown apps, lots of things. The main thing for those of us that have been lucky enough to kind of be in this space for a while, in these big data projects, if you go back 3, 4, 5 years ago, no one was really doing this. Everyone was doing batch processing. Now batch just meant, okay, we did it once a day, then we did it twice a day, then we did it every hour. And batch kind of dies in for a lot of these big systems about every 15 minutes. It's about as fast as we can kind of turn the needle and try it again. So we're talking about, obviously well below that threshold of events that we're talking about through a real-time system. I guess the main thing to think about here is that, the data we're loading here may or may not have come through a batch world in addition to streaming. If it was, then we can let streaming systems do what they do best, which is look at data, make decisions, and throw data away. Because while what people are really doing with these systems now are they're using them as pure ingest only. In fact, I've seen people that have a system that creates a file, and they drop a file, and then they have a process that rips the file and throws it into Kafka. Then they fire up Storm to read from the Kafka message queue to do what? To write it to HDFS. And I say, well, you're already done. You already have the file. You're done with it. So it's fun, to do resume-driven development, but these tools are hard, and I would encourage you to find a problem unless you just want to learn something new and interesting. And Storm is one of those. All right, so I'm having one of those Trump moments with my dry mouth here, so I apologize. That was a terrible joke? Nobody liked it? I'll do it like, how do you do it? Tough crowd. Okay, conceptual model. All right, so in Storm, what's pretty unique about Storm is Storm actually works on single events at a time. What's kind of happening in these streaming framework systems, they actually work on a concept called micro-batching. They work on a number of events together, maybe enough events for maybe a second or two. At 1 million transactions a second, that's 1 million events that showed up at a time. And that's not bad. There's nothing wrong with this micro-batching concept. But Storm at heart was built from the ground up, thinking about an event at a time flowing through a system. So they use the old database term, the old tuple, row of data, a unit of work. This looks a little bit like an XML. It's just values. There's no header information. This is a first name or last name. So if you had a tuple of an employee ID and a first name and last name, you'd have a 3 tuple. You have 3 fields. So we're going to just have an immutable set of data ripping in, rolling in. That stream that you hear about in stream processing, what is it? It's just a bunch of these tuples getting thrown at something at a rapid pace and dealing with those and working on those as we go along. So we think of those as unbounded mainly because these systems and these workflows, we should kick them off and they should just run. They should just run forever. That's the expectation that we should be doing. A little buzzword, abstraction, because you'll see when we look at the code, we don't really write a stream or anything. We just emit data and we consume data. And we let the framework, this runtime framework called Storm, take care of that for us. So that's just data flowing through the system. But there really are 2 major stereotypes as we look into code that we would write or code that we use off the shelf. The first one is kind of the bringer of data maybe into a workflow. We call that a spout. There you go, spouts. What they do, they gather information from a socket, maybe from a file system. Maybe they look for a file to show up and they read everything out of a file. Likely they connect to a messaging platform such as Kafka. Something like that would be a good connection point or a good spout piece of data that it's listening to. Raises them up. And as this picture, it probably isn't confusing at this time, and I'll keep it very simple in here, but think about this as we go along. These components are not bounded to have only one kind of stream. They could emit many kinds of things. They can consume many kinds of things. We'll do something, create something, something, consume something. We'll do an A to B, B to C kind of model. So as I said, message queues are probably, message queues, Storm is not a message queue. A message queue for Storm would be a great thing that we built a spout around. And again, if we use something kind of mainstream, then we would hope someone already wrote a spout for us to do that for us. That'd be good for us. We'll build a simple spout just to kind of get it going. All right, so spouts create data. They raise these tuples. They inject them kind of in the workflow, the stream engine. But what do we do with data? We have a stereotype called a bolt. So we create things that do something. Maybe they just ingest it. Maybe they take a record and they put it in HBase. Maybe that's all they do. Maybe they're looking for thresholds. Maybe it's a system that's monitoring smart meters and it's looking for, hey, my goodness, I just saw this update from somebody's home, a residence. I'm getting this emitting, and oh my gosh, they have a usage in that last window that was 10 times beyond it. So they maybe hit a threshold, and maybe they trigger an alarm system to say, hey, there's a power issue there. Or maybe it's a water main break if it's a smart water meter system, something like that. So they can, and in fact, this is your code. We don't really, there are bolts out there that know how to talk to other systems, a SQL system, a NoSQL system, another message queue. Sure, there's those technical transformation bolts, but for the most part, we write this. This is the code that we write. We'd say, what do we do now that I have this event? What's important to us? So we can read and write. We can do something. We could join. We could have a bolt that's listening to two different kinds of streams and kind of keeping track of what's coming in here and coming in there, and maybe keeping a little bit of past data, trying to find matches and say, oh, there's a hit here, there's a problem here. Maybe I should do something. So there really are arbitrary code. They can, if they'd like to, they don't have to, they can also admit other data. So we don't really have, these are a very distributed system. It's not like there's one system called NiFi out there that all lives kind of in the same process space, so that makes it pretty easy. We just kind of reference the data. We are inherently pretty distributed in this storm world. So by definition, because of that, we don't inherently just, as we get something, continue to pass it through. As you receive something, it's up to you to decide what you want to send downstream. So often we would, like we do in a lot of big data things, get rid of columns that we don't need, get rid of rows that we don't need, and then maybe we omit some other things. So spouts, bolts, they all kind of talk about this tuples, and you put it all together with a thing called a topology. That's the workflow. So if Storm had a visual builder, you would drag off the palette and drop and double click and that kind of stuff. Storm doesn't have a visual builder. It has a text editor. There is a project out there called Streaming Analytics Manager that is bringing a visual builder to streaming frameworks. First one it's implemented, it's using Storm today under the covers. It'll try to do other streaming frameworks, but it's not part of Storm proper. So the Storm team doesn't have a palette, drag and drop, Visual Basic kind of thing. It's writing code and wiring it up together. All right, so we got this topology. And I don't know, before I came to my Hadoop world, maybe I'm just a bad programmer. I never talked about this thing called a directed acyclic graph, a DAG, but boy, we talk about that all the time. When you work for a Hadoop company, every other word is DAG for some reason, so I have to go look it up every once in a while. And to my understanding, a DAG is not a lot more than a kind of pre-described set of flows and activities that one would go through to get something done. So nonetheless, we have this collection of spouts and bolts that come together that identify how data is going to flow from start to finish and kind of execute through some kind of topology. And then a weird thing, if that's probably not hard, right? We can imagine, great, what are we talking about, Lester? We're building code that implements an interface and some other code that implements an interface, and we're telling, hey, send the data here. Cool. I mean, that's not hard. But what I think the power, so that's cool. We have this kind of abstraction that lets us build in, I wouldn't say loosely coupled model. The truth is, you are thinking about your whole workflow, so you're probably not, you're not going to build this perfectly, extremely reusable bolt. It makes sense in 2 or 3 other things, but it makes sense around your data. What really comes to bear that makes, I think, Storm really shine is that by doing this, by separating code in these chunks of activities and wiring them together, we can then apply, this is a streaming framework for big data, right? This is that delicious word, big data, Internet of Things, so on and so forth. But the real power that I think that Storm brings to bear is we can control via levers how many of each one of these things we need to make our topology keep up. Meaning, let's keep it simple. We don't have this and this, we just have that top thing. We're listening to 1 million transactions a second, and one instance of that spout seems to throw 1 million transactions in the workflow and the framework's happy. But if this guy and this guy, they're 2 different kinds of bolts, they care about that same data. If this guy can only trunch to 500,000 transactions a second, I need to do something. So I can individually scale these different components. So I can say, you know what, I'll need maybe 3 of those, so I can run at 1.5 million transactions a second. But maybe this guy, we clocked him at 3 million a second, leave him alone. and vice versa. Maybe this guy's a really dog. Maybe we need 20 of those things for some reason. So we can individually turn on and turn off, have metrics and monitoring around all those activities. Okay, so this picture is really busy, but it's trying to show what I just said. So I'm gonna let you eat that piece of pizza, take one more sip of water. So on the left, a simple logical topology, one spout, 3 bolts, kind of as you see, bolt A and C are both listening to spout A, tuples via the stream, and then bolt B is waiting for A to raise it something else. What we're showing here is what if everyone except for bolt C needed 2 instances to run? Fair enough. A lot of stolen from a bigger slide, so don't worry about all these layers here. They do mean something. They're important, but not so important for today. We're showing that, maybe in an extremely distributed model, we even have every one of those instances on a completely different machine just for fun, which is, to be honest, not so unheard of in Storm. But what we're really trying to show is this instance 2 of spout A knows that, bolt A actually has 2 instances. So he has to kind of make a decision, what do I do here? What would I do here? You're writing the code, what do you do here? What do you do when the downstream guy has 2 players? What's that? Why not? Why not? So you have to do something. You have to do something, and that's a very popular answer, and that actually probably is the answer most of the time for most processing out there. So Storm, in addition to letting you scale these things independently, will give you some opportunities. So they call that as stream grouping. They let you define what do you want to do when there's more than one downstream. And I'll show you, I think on the next slide, some of the popular ones. Where do you configure these things? So you configure them, the number at launch time. I'll show you when we launch this. You can actually say a parallelization hint. It's not a hint, you're saying I need 7, I need 2, I need 1. But you can change that at any time. At runtime, you can change it, you can elastically scale it up or scale it down.
You have to set up your own HA proxies or load balancer to start.
Yeah, it's all inherent within the software. So he's taking care of that. The string grouping, who goes when or why, that's all Storm. So there's this kind of runtime. So it's not just a framework that we compile with and then we go run. You'll see in a bit, we have a running system that we come to with some a jar that represents our topology and say, now that I got it figured out, could you run this? So we're not completely in control. We honor the contracts, and we'll be off and running. So at runtime, we can change this. The thing we can't change at runtime, at least not today, is what we decide to do. So if you want to do a round robin, and you configure it that way, because you're going to see it, you say, yeah, do a round robin. If you change your mind later to one of the other options, you'd have to stop it. Or you'd rebuild it, stop it, flop it, You can make it pretty fast, but you got to stop it and restart it. So there are some things that it can't handle. So what are those things? There's about 7 or 8 of those things, but the ones that people see in practice are, randomized. I mean, not randomized, round robin. They always say random, but it's round robin. Go here, go here, go here, go here. You got 3 of them, go 1, 2, 3, 1, 2, 3. Pretty straightforward stuff. But a real powerful one is this notion of fields grouping, meaning that maybe if downstream I have 3, maybe I'm trying to keep a running average of something, and it's, I don't want to know, I'm trying to figure out average amount of sales per hour by billing customers' home zip code or something silly like that. So I'm getting these credit card transactions, and I want to round them up and figure these things. What we're trying to do is say, hey, look, it's a hashing algorithm. It's saying, hey, this particular field or this collection of fields, hash them, do the old modulus, pick however many instances there are downstream, and then intelligently route that particular guy to the same. It's kind of a sticky load balancer, I guess you can say. Anytime I see the field called zip code that's value 30004 up there in Milton, send it to number 3. Anytime it's 90120, send it to number 1. It doesn't matter which one it goes to, but we just want to guarantee they all go to the same place. Why? Because our logic's thinking about that. We're trying to say, hey, I want to make darn sure that I know everything for this particular field. They always come to me. Does that make some sense? I see 1 nod, that's good. It's 2 days before Thanksgiving, that's probably good. 2 nods. If it's not, I'm going to use fields grouping in my example in a minute, and hopefully it'll make a little more sense to the real example. And then lastly, not lastly, but the last of the real common is this notion of like an all, meaning maybe I have a topology, a stream that when I raise it as a spout, if there's 10 instances downstream, send all 10 that event. Well, I can tell you what, that's not for scalability because it ain't going to go any faster. In fact, it'll be harder because now 10 people have to do the same amount of work. So this might be maybe a scenario where you have a second or third or fourth kind of stream that's in your workflow, and then possibly it's a little lower rate of frequency, and you'd want everyone to know about it. Example, maybe you're doing some kind of supply chain and you really care about the weather. So maybe you wire up everybody and say, hey, I get weather alerts. Those don't come in a million a second. They come in a few a minute or something like that. Spam everybody because everyone needs to be aware of that. Those are those kinds of things. Or more realistically, 9 times out of 10 or 4 out of 5 times, we use this to kind of like create the dog food model, implement a dog food model when, hey, if these systems are going to run all the time, how do you change thresholds? How do you change runtime models? How do you change things once the batch system has a better answer? You create like a control stream. So you kind of create some way to surface events, configuration, that kind of stuff. And you say, yeah, let everyone see it because everyone can act upon it. There are others, including some homegrown, build your own kind of algorithm that decides how I want to route things. I don't know if that made any sense at all, but there we go. Any quick questions? Give me a second to drink some water. Well, no one ran out the door, so I guess that's good. Okay, we're almost to code. That's what I think everybody wants to see anyway. Yes, please.
So what will be the ordering mechanism when you are saying that same field will group the same task? Say for example, one is for, it cannot be relevant, but one is for create and second one is for update. So what will be the ordering?
So that one's going to be tough because it all depends. Thank you, in the back. I'm going to hold that question in, but I'll give you a quick answer. It all depends on how well that.
Repeat the question.
Sure, thank you. The question was, what if I'm maintaining a system that's has to think about ordering? This thing got created, this thing got deleted, this thing got added, and that order matters. The problem in these systems is, if you think about it, remember I said that exactly once processing is the real animal? Something could go wrong with one of those millions of transactions a second that could have failed. And the system is built and has concepts like reliable operations. The system can notice that, and the system could attempt a replay of something. Well, the problem with that, in classic Storm at least, is there's really no answer to that. If something failed, it's going to trigger back up. So it means you probably have to build some smarts. If you need that kind of understanding, you got to build some smarts in your bolts. There are some things called Trident that I'll just mention like that much, that has stateful, some more advanced stuff that actually solve that. But at heart, you're kind of on your own.
At the same time, you mentioned it's exactly once delivery. It confirms, right?
With Storm, we have to go to Trident to get exactly once processing, and we have to implement code in the framework that's the way it handles state. And it's really about making sure let's do this one at the end. But in basic Storm, classic Storm, event level Storm, that's a really difficult thing. We got at least once and at most once kind of concepts with classic Storm. I'll be glad to hang around and talk about it a little more with you. They do have a framework called Trident that would help you get exactly once. Okay. All right, so in compile time, guess what? We need to write some of this code. This is what I'm going to do with. We're going to do this together live in a minute. This is an example of a spout. Obviously, there's an interface out there, but we're going to use kind of an abstract class. It's some kind of object that's going to get constructed. So there's housekeeping. There's like an open. There's a close method. It's not up there. Kind of do your thing, get set up, get ready to go. But the real work that gets called over and over again is next tuple. So I'm a spout. I'm raising tuples when the framework asks me them, and I emit those out there. So we got but an extremely simple example of emitting a random sentence. And it's not so random. There's only a handful of them there, and raising them out there. Imagine this was maybe a little more sophisticated. Maybe it's a Twitter connection, right? It's raising tweets or something like that. Right here, we're just going to raise simple sentences. So we're raising data, and this data is only a string. We can raise all kinds of things. Where you declare what kind of thing you are raising is this kind of one-time called event here, a method called declare output fields. Here's your opportunity to say, maybe you raised customer ID, first name and last name, and state or something. So you'd say customer ID, first name, last name, etc. You could have, fat, rich objects. They could be highly rich objects. You got to register with cryo. The kind of theme here is be as lean as you can, because we are talking about a lot of transactions, a lot of seconds. So what may happen is, even if you have a fat object, you might wire up another bolt right behind it that does what? Throws almost everything away and trims it down to primitives. So we're not limited to primitives by any means, but that's a kind of a common pattern that you see being used. So we'll declare output fields. This is a way to say, this is what I raise. Again, so that gets called one time, and these get called a bunch of times. Boom, 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 boom. There's throttling, there's some ways for the system to kind of slow down when things are getting, some early back pressure controls that are there. Some rudimentary, I guess is it fair to say, rudimentary back pressure controls. So spout raises tuples. The acts and the fails, we'll just save those. They're about the kind of replays and those kinds of things. And then a bolt code is not really much different, right? We write a code. I would say the only thing different, it was clearly there was two different programmers that came up with the interface, because the spout uses open and close. We use prepare and clean up as our house cleaning methods, okay? We use next tuple there, and we use execute over here. And of course, that's a popular method name for a couple other reasons, of course. But just like a spout, in case we want to raise anything, we would need to declare what we're gonna raise. This guy actually raises a sentence, because what he's gonna do, he's gonna be handed a tuple. He knows he has to have some intimate awareness. Hey, that tuple has one field, and it's a string, and I'm gonna slap some exclamations on it, and then send that back out. We're gonna do something a little bit more sophisticated than that ourselves. But we're coding an execute, hand it a tuple, do something with it, and we're gonna code, what do we raise up?
So
we're done.
At what point does
Yeah.
the spout collector get bound to the, trying to see where they get?
You haven't seen it yet, you're exactly right. It's the next slide, so the very next slide. So remember, we had here we go.
You declare the random string thing, and just look. Go ahead.
No, go ahead. You want to say, how do you wire these together, right? Here's what you do. So because we don't have a visual builder, you look to your left and your right and say it's a group of 3. You decide a group of 3 or a group of 30. You decide how much documentation your team needs, but maybe our team decided we'll use this kind of Lester modeling language and do something silly like this on a wiki page, and we said, look, there's our topology. So we agree on what we're trying to do first, and then we get to the keyboard and wire it up. So what we're saying here is we want to raise something out of this guy, consume it here, and then whatever he raised, consume it here. We'll do the round robin. We don't care if there's 1 or 100 things. So that's what we want to do. And then how do we do it? Well, we do it in code. There are other ways to build topologies. One called Flux that kind of does a JSON version. There's something called Storm SQL. Can kind of define a topology in SQL. I'm still trying to wrap my head around that, if it's good or bad. But nonetheless, what we do is we need to kind of get a hold of a topology builder, and we just kind of explain what we want to do. Hey, builder, let's set a spout. Let's call it something. And that name, you're going to see it in the console when we kick this thing off. That's a name that we decide to do. What is it? It is this kind of class, a test word spout. Great, we got something that's emitting things. Then we want to say, in this case, because we have a little simple spout and 2 bolts, let's just wire one of those up. So you see it right there, set bolt. We'll call it exclamation 1 or exclaim 1. What is it? It's a exclamation bolt, sure. And what we do in Storm is we wire backwards, which sounds weird, but it's correct if you think about it. This guy doesn't know who he throws to. It's the consumers. They say, I care about something that's coming from that guy. So we say, and this is those, remember, shuffle and fields and all. This is that kind of streams grouping. So we say, let's do a shuffle grouping on the component called words. Well, in this case, words is that guy, that spout that we configured there. So we just create him and wire it backwards to words. And in our case, we have another one, same situation. Let's call it exclaim 2. Again, these are whatever strings you want. There's my class, new exclamation. And then I care about stuff that came out of exclaim 1. So that's how I'm wiring up, at least that's the answer I have for you. It is the answer. I don't know if it makes sense. We do it kind of coded. We say, we kind of think of it from a subscriber model. Everyone's a publisher. Everyone can be a publisher. So as you instrument, as you define your topology, visualize it first. Whatever that is, back of your hand, in your mind, know what you want to do, and then type it. We just think about we have to wire backwards, which is really okay to me because you're saying, hey, I want to consume data that came from that guy. That guy doesn't need to know, is there one guy or 100 guys, because it's not his job. There's an orchestrator running. Storm is a runtime orchestrator that's going to instantiate this guy, instantiate this guy. He's going to call he's going to call next tuple from him, and he's going to inject it in that way. To be honest, it's probably going to do something a little bit more fine-grained than that. It's going to wire them up for us, but that's okay. I think it's a way to visualize it. Yes, ma'am?
So the spout is going to be the first originator?
Always spouts in Storm, and if you want to know just the short answer why there's just some frameworks just have a thing called like a processor. What's so special about it? In Storm's world, this drives things that originate here are the things that we can replay. If they don't finish them or any of their derivative data doesn't quite finish because of an error, because of a timeout, then we say, hey, if we have reliable operations, we'll go back to the source and say, let's replay that thing.
So you cannot replay from the bolt?
You can, no, you can't. You can fail from the bolt onward, which will trigger it to replay from the beginning here. And this is that a more advanced conversation that you and I can have on the side of, okay, that's great, but what happens when? What happens when?
Okay, and what is that words and it has something to do with the field which we have decided?
Which one?
The words explain one. Or
Sure, these are, you're gonna see them in the UI. These are just our terminology here. So you might have something.
No, I mean, is this the same one which you are going to define in the field?
I'll show you in my code example, I'm gonna do a fields grouping, and I'll show you how you connect it to a particular field, if that makes any sense. This is the thing, if it was fields grouping, you'd have to also say the field or fields I care about are from exclaim, routed intelligently based on this field, kind of a thing. All right, so we wired it all up. Again, some boilerplate stuff. What do we ultimately do? We submit this topology. This is the only string that I would say in a real system that you want to be careful about. These are going to live from the runtime system in this topology. I'll show you that in a minute. But if you have a system that's running 2 or 200 or 2,000 these topologies, you probably don't want name collision here, and you probably want to be able to intelligently look at that because it looks like it's a open source, administrative screen. It looks kind of like Craigslist. It's all gray, it's boring, it's a list of things. So we want to kind of put some of our own smarts to those names. Time check. Okay. All right, so let's do a demo. Okay, we made it to a demo. What we're going to do is, who needs a quick explanation of a word count? Y'all are being so nice. So word count just says, I don't know, look at a string or a book or the Library of Congress and find the distinct number of words, the distinct words in that corpus, and give me a count of how many times each word was used. We do that in Hadoop like all the time for some reason. We seem to think that's fun to do. All right, so let's build a word count topology. And I didn't show anything else, I just got to it. Great. All right, so I cheated a little bit, and I kind of got everything stood up and off and running. Is that too big or too small? Okay so far? Great. Made it too big for me, but I think it'll work. All right, so if you remember the picture, we want one spout, 2 bolts, we're done, right? Okay, so I went ahead and started this spout for us. I got this thing called the random sentence spout. It's the same thing you saw earlier. What is it doing? It's randomly picking one of these guys and emitting it. Nothing special. The only thing missing from this guy is that we need to declare what kind of fields we're going to raise up. Yeah, one of those. We're going to raise a word. Yeah, we get a sentence, and we're going to raise a sentence, sorry. Sentence. Great. I think we're off and running. Yeah, he's good. All right, so I got a pre-built spout. It made it quick and easy for me. Now I want to create a bolt that takes that word, that sentence, and splits them or tokenizes them, and then erases a bunch of independent little words. So let's just say split sentence. And I'm going to use a silly naming convention and just call it split sentence bolt. And I'm going to extends a base rich bolt. And I'm going to not cheat, say, let me cancel. I want to do a basic bolt. Basic bolt, yeah. Yeah, that'd be better. All right, so I'm going to go ahead and tell you what I'm trying to do. I am going to declare, anyone have any ideas what I'm going to raise out of this? I think I said it a moment ago. So he's receiving sentences, and what is he going to emit? Words, thank you. So he emits a thing called a word. How do we do that? Before I start typing it, what am I going to do, right? I'm gonna get called next to execute. I'm going to be handed a tuple. The tuple is a string. I'm going to split the string. I'm going to be low tech. I'm just going to do it by spaces. So Lester, comma, and Lester are two different things, but that's okay. And then that's it. I'm going to emit each one of those. So every sentence I get, I'm going to emit, 4 to 10 or something like that words. So let's just say, let's get the sentence out of the darn thing. Tuple dot get string by field. What was the field name? Sentence, I think it was. Sentence, yeah. So I got the sentence. I want to do, I think it was string. Which one am I using here? Let's do string utils. Let's just split that sentence. See if I can get the right one here. I want, which one did I say I wanted before? I'll go with that one and find out. Sounds good. All right, so I busted, actually I need to do something with that, don't I? He probably is. Come on. Thank you. Words equals. How about that? Great. Let's do a for loop. What was it? Words. Y'all got me on. Is it words or word? Which did I do it the wrong way? Did I flip it? Thank you. Thank you. Great. What do we want to do? What's it squiggling at me for? Words. I don't know what that's not right, is it?
String before word.
Thank you. I was trying to solve two things at once like a bad person. Thank you. String, word. Great. Good for me. Then what do I want to do with this? What do I want to do with the word?
Send it to the next thing.
Emit it out. So how do I emit it? I can use this basic output collector emit method. And I have to kind of use a wrapper class called values, new values, and I'm going to raise the word. Yeah.
Do you normally
Yes.
loop through it, or is that just something for the demo?
Just something for the, well, I'm not trying to show you good Java program. I'm just trying to say, what are we trying to do here? I'm trying to get a string and I'm trying to erase just all the individual strings. If you want to do something more sophisticated than that, yes. If the question was different, the question is, would I emit a bunch of things? Which I don't think that was the question, was it?
No, more just is there kind of a helper in the storm to just say, oh, here's a list of whatever.
No, because probably this is not the normal use case. Probably we're not usually getting just a series of autonomous, they're all the same things. We're usually parsing something that's, this is a number, this is a join key. They're different values, but so there may be one that I'm not aware of, but I don't think so. All right, so I'm gonna, if y'all don't mind, let me be a terrible programmer, because it'll be easier to see it in the code there. Thank you. I'm just gonna say splitter. You'll actually see that he does some log messages to help us out here, but I just wanted to cheat a little bit. Word. Yeah, that'll probably be good enough. All right, so I think I got him done. I'm missing something here. New fields. Field is word. Declare but fields. New fields. Oh, cheat. Okay. Oh. Not declare. Declare. Come on. Output fields declare. Not declare it. Thanks. All right. I'm going slower than I wanted, so I apologize. See what we did there? Nothing too scary. And at this point, I really want to do the other guy, but I'm running out of time, so let me just be a cheat, because I am getting kind of heckled in the back there to go faster. All right, so let's have a counter bolt. This is our magical guy that is going to get those words. We doing good in time? Okay. I'm going to cheat anyway. Now that I feel. Yeah, look away. You watch my YouTube video, I do it all, and I don't fumble somehow. I don't know what happened. Let's see, our word counter bolt. Yeah, let's steal him. And I'm just gonna, you know what, let's just cheat with the whole darn thing. Hopefully I called it the same name. Yeah, everything's in the imports now. Why not? I'll explain it. Oh, come on, that'd be too nice. Okay. What did I do wrong here? Word, oh, I called it a counter bolt, huh? Counter bolt, will that fix that? Yay, counter bolt. Okay, so what do I always think about what I'm trying to do. What am I trying to do? I'm trying to emit a bunch of independent words, and I'm gonna have like a rolling average. Every time I see a word, I'm gonna update. I'm gonna find out that I already see this word once or twice. Yes, I did. Increment it by 1, and then raise it up again. So I'm gonna get called a word at a time. Splitter, the sentence create a word. That bolt's going to create maybe 4, 5, 6 words, and each one of those words I'm going to call my kind of counter bolt. And then for each one of those, again, I'm going to be very low tech. I'm just managing it and a little in-memory map in a class level map there that says, hey, for string and integer. So I don't know if I'm talking too much. Let's see if it makes some sense. I get handed the tuple. I take the tuple. It just has one field. It's called a word. That's right here on line 17. Again, low tech. I got a little map. Probably me, I like this thing called HBase. HBase has inherent increment counters that are really nice. So I probably wouldn't do this. I'd probably just write to HBase really fast. But I pull from this. I say, hey, did I at least see this word one time before? Yes or no. If not, kind of jump start it with 0. And then I'm just putting that word and count back. So I'm keeping this kind of in-memory representation. And in fact, I'm going to scale this bolt. I'm only going to do 2 of them. But the fact that I'm going to scale this one, if I want this to be accurate, I have to do that fields grouping. I have to say, make sure the word the always goes to one of the bolts and always goes to the same bolt. The word Susie goes to one of the bolts and always one of the bolts. And in fact, that's the one real catch with fields grouping is if you use fields grouping, I told you can be very elastic about how many instances you want. Well, you can, but you have to think about, if I went from 7 to 17, there's no more guarantee that the same word always goes, that same field will go to the same one. So you kind of have to own that in your code to say, is that important or not? For a word counter, it's probably not a big deal. For a lot of tracking systems, it'll work itself out in a few minutes. Yes, sir.
Any threading concerns?
Do you want to spawn a thread here of your own and do you want to spawn a bunch of threads? So every one of these instances is on its own dedicated thread. So Storm is kind of managing that, and it kind of, generally speaking, it would be probably smarter to not do a lot of multi-threading here. You have to say, what am I doing that would need a multi-thread, and maybe kind of rethink about that being an instance of a bolt or a spout. So I'd have to go back and scratch my head. But I think the short answer is don't be spawning lots of threads yourself.
Do you have to worry in your code about threads that have been spawned for you?
I don't know if I got the perfect answer here. So I would say you don't have to worry about you would write this code as if you are on a dedicated thread. You're not too worried about anybody else. You're not going to be you're isolated from everyone else out. But
I think answers the question.
Okay.
The isolation.
Okay. All right. So I cheated. Put that together for us, and I am going to.
I think your mic died.
Oh no! I sat on it probably. Thank you.
So I got a question.
Please. Hello. Test. I'm going to cheat on the other guy too. Go ahead.
So if we have multiple instances of this bolt running in multiple server machines, certainly it's different VM. So these kind of are not distributed, right?
This implementation would work just fine because as long as we don't change the number of instances, it's not going anywhere. It only lives in memory. Mm-hmm. But I can guarantee as long as I don't change the number of instances of the counter bolt, that those counts would be perfectly fine. Because I'm always going to guarantee a certain word goes to a certain place, and he keeps track of it. So, yeah. So in other words, if you want to keep some kind of running average over 30 minutes or an hour or something, because that's important to you, and every once in a while with that day you might alert someone or do something with it, that'd be perfectly fine. This would work great. Problem with that, again, is that change that number. You have to expect that for a little while until your logic of 30 minutes works out, you're going to have some interesting anomalies that could occur. And that may or may not be a big deal. If it's a giant deal, stop it during topology and start up again. I mean, it's, not what I'd love to do. All right, so let's run this thing. Run it, topology. And I am going to also cheat. Feel terrible here. Like a terrible, terrible person. But since y'all saw my topology, it's not that hairy. All right, let's grab the imports separately. You know what, I'll cheat and get the imports too. Let's get ahead of the import game here. Sure. And I'm not sure why I missed the package there, didn't I? What I did before. Hopefully that sorted itself out. All right, let's trash that guy. All right, let's do it the way I cheated before. I'll just steal the whole class. All right, and we'll call it a run it. Get that saved and stuff. I missed it, huh? What I missed?
You missed an
It's
item.
outside of the stack.
P-O-P-O.
Lowercase r.
Yeah, no, earlier I did the same thing. Maybe I did put it inside the pack. Maybe that's what I did. We can fix that. We can fix it. We're going to create it in the package. Dude, wake up. All right, dude, wake up, class. Good for me. All right, I'm going to paste it again. Dude, wake up. See if that solves it. Fingers are crossed. Couple word count bolt. We actually call that a counter bolt. Counter bolt. What else is all red? This guy needs to go away. Probably didn't even save it, huh? You guys are killing me here today. Sure. All right, so I got a dude wake up topology. What is a dude wake up going to do for us? As we said before, we're going to wire up a spout, a generator. We'll call it generator. This is our term. What is it? It's that class, that random sentence spout. There's that first way we can say how many do we want. We just want one of those to get us started. We'll do the same thing. We'll configure up a split sentence bolt. We'll call it splitter. Excuse me. We'll just use one of those. I'm running this in a pretty small environment, so I'll keep it simple. And then lastly, because I wanted to show off that fields grouping, I'm going to wire up something I call a counter. It's a counter bolt, and let's have at least two of those, so each one can have different words. And then instead of the dot shuffle grouping, we'll do a dot fields grouping. We'll still say, listen to splitter, get data from splitter, and then we'll have another argument here that says, okay, what field or fields are going to be the thing that we hash against? So we're just going to take words, basically, trying to turn that a number divided by, do a modulus operation and decide if it divides evenly with 0. Divides evenly with 2 or not. Thoughts on that before I try to run it?
What is that parallelism?
Parallelism, remember we said that every instance of a voltage spout could have, one to a lot of instances of it. We parallelize that. This is our way to initially say, start me at. I'd like to have 10. I'd like to have 20. If you're topology, to do what you need to do. You need 10 of these. Don't start it and then go to the console and then play it up. No, I need 10. Let's start with 10.
So in counter, we are saying that there will be 2.
We're saying there's 2 because we really want to make that point that, well, when we scale something like that, we don't want if we scale it and we round robin it, then the goes here one time, another time it goes here, okay, so there's 2 thes, and then the third time it might go here, right? Oh, so we have 2. So we would have no way to kind of know holistically how many thes there really were unless we guaranteed that the will go to the same place. I was trying to have at least, you could still say fields grouping and only have one, I was trying to make sure we make it a useful example.
So I was thinking that the topology builder was really just the logical association, and that there was a different abstraction that actually dealt with the scale, but the topology builder actually has the scalability.
There is a separate person element that's keeping track of that, but you can, while you're describing the topology, go ahead and tell that separate entity what you want it to start out with. That's what this is letting us do. So we're not bound to only have one forever. This is just a starting point. This is our bootstrap, I guess you could say, to get started. I'll show you how to change that in a few minutes. Well, I'll tell you about it. All right, so a bunch of config stuff, but I didn't tell you too much. And then I was saying, look at this word count solution. That is something important. So it's often here. We've got a Java main that does something. I have to run this Java main. So let me take a moment and see if there's any. I guess I can build it in the background. Questions so far before I cycle back? Kick off the build in the background there for us. Concerns or questions so far?
Yeah, I'm sorry, I did not understand that when you say that you are going to run two different counters. So if two there will go into the first one and the third there will go to the second one, and the two different instances will have two different maps, then how will you have the equal to 3 count?
Well, because we're guaranteeing the will always be 3, because this guy, we said there's one of these and 2 of these, right?
Yeah.
So in this case, these letters are the words. That better? Take all this off. You're killing me here. I don't know. I broke the microphone. I think I sat on it or something. We're just letting the framework know that, hey, because there's 2 of these, look at A, and you, not me. We're asking someone else to take care of it. We're saying, hey, Storm, guarantee that this A will always go to instance 1. D will always go to instance 2. B will always go to instance 2. C will go to 1. I mean, he's going to guarantee that for us. That's all. Nothing more fancy than that. We didn't write code for it. We said, you deal with it. Here's the hints that will help you do that. Does that make some sense? Hope so. Okay. All right. I didn't run it yet because, as I said, it isn't a framework that I compile to and I just kick off and run. I have to submit this to some kind of running environment. Not that uncommon in these big data super scale solutions and that kind of stuff. So you're kind of seeing a little bit of a hint of what some of the terminology is out there. This is the highest level architecture. So when you talk about big data solutions, you talk about clustering technologies, you almost always have a couple different runtime stereotypes. And almost always is some kind of worker, master-slave, master-worker architecture. Storm is no different. In fact, you kind of probably can start to figure it out. Nimbus is the master and supervisor is the worker. Process, this is the scale out. I'll have 3 of these, 300 of these. These are machines I'm devoting to kind of run my topologies on. And then in the middle is this guy called Zookeeper. Anyone played with Zookeeper before? A couple Zookeepers? All right. We'll be here all week. Tough crowd. I have to humor myself if no one else, so bear with me. So just to give you a quick view, I think I'll cycle through here, but I'll tell you this real quick about Zookeeper. I always explain it this way, and I keep waiting for someone to come hit me in the back of the head. If you know what a Windows registry is what? Is this kind of hierarchical system, and what those Windows developers do? They put configuration information in there usually, right? A bunch of little cryptic things like Frog Daddy equals QQ9Z. What does that even mean? We don't care. It's just their place to put stuff. So Zookeeper can do a lot of things, but one thing Zookeeper can do is be a distributed a little bit of a distributed configuration manager. And with that said, I'll show you these next couple slides. In fact, it allows this kind of master worker architecture to limit the times that the master has to directly talk to the worker. So they just say, hey, why don't I have this super on steroids Windows registry in the sky, and why don't I, instead of telling supervisor 12 to do something, the worker process number, machine number 12, why don't I just trust that we all participate in this Zookeeper framework that guarantees that they're listening, I can write some information, and they'll notice the change that occurs. So it's an intermediary agent.
Jim, do your naming service or anything like that?
No, I think Jenny naming services get you started, right? You use them for a quick lookup, and then you're off and running, right? We don't beat them up. These systems, HBase, Kafka, Storm, and many others, they leverage this Zookeeper like crazy. I mean, they just beat it up. They write a lot of stuff. It's Yeah, it's a lot more than installation. It's the communication that's occurring. Hey, I'm doing good. I'm doing bad. Here's new work to do. So all that's happening. So it's basically you're registering kind of call. Under the covers, you're saying, hey, I care about the folder called I'm Supervisor 3, and I'm going to tell me when something's changed. And he writes changes. Hey, here's your new assignment. Here's what, so we're changed. So this guy's in charge, but he's not talking directly. He's talking here. Why? That way, if he disappears for a brief period of time, the world keeps on chugging, and we just can't do very big life cycle things. We can't start or stop a topology, and we cannot re-parallelize, but we can run like crazy as long as, we can run as long crazy. All right, so put it together, what happens? We're gonna use a command line operation that says submit that class, that Java main that we created, and basically what are you gonna do? You're gonna ship off, we're gonna build a jar file, we're gonna ship a jar file to that guy, and he's gonna go, okay, I know what's happening in my big wide cluster, and I'll assign you appropriately to make sure it's all going to run to the scale that we want, and considering all the other topologies running. And what is he going to do? He's going to write it all down into Zookeeper so that those supervisors will notice that as soon as something was changed, they'll get alerted, hey, your directions have been changed. You were in the Air Force, I was in the Army, directions change all the time. So directions change, and you act upon it. So Zookeeper's going to get that. And likely the directions are, hey, go run this thing that just got created. And they're gonna not, if there's 20 or 30 instances each one of these machines is gonna only one time go back and fetch that kind of big fat Uber shadow jar, whatever term you like to do, bring it local so it's okay to run. And then these supervisors run a bunch of different JVMs themselves. So your real topology is running down here. It may be in one single VM, but I'd say kind of the thinking and the practice and the intention of Storm is probably in a bunch of different VMs at any given time. So it's very, very serialized, heavy, uses cryo serializer. These guys are kind of busy and talking to each other. I don't know if that made any sense. So there's an master worker architecture. You submit to the master. He hangs on to your binaries. He decides where they go. And then those independent machines get the data and then start running and make it happen. I don't know if that makes any sense. Question, thoughts, questions? Thoughts, ideas? Okay, let's run ours. All right, so we built the jar file, hopefully, in the background. Yep, build successful. We've got, at this point, we probably have a target directory, yep. So I have to go run this thing on a Storm cluster. I've chosen to use, I work for Hortonworks, so I use a Hortonworks kind of framework that lays down Storm for me. You have a couple of them, actually. I'm just going to do it SCP, hopefully. Hopefully that's still in my history there. Of course not. Okay. SCP minus P. All right, so I want the big fat Uber jar. SCP, push it over the machine. And there's an easier way to do it. You don't have to do all this for it to run one time. I want to do it all. Secure copy, push it over the Storm, word count, 2. Let's push it to root at 127.0.0.1. Storm jars. Yay. All right, so we push the file over there. We're already logged in over there. There is said file. Let's see if I can remember how to kick this thing off. It's something like Storm jar, the name of the jar. The name of the class, word, count, what was it called? Dude.
Wake up.
Wake up, dude. Dude, wake up. Dude, wake up. I see it on the side there. Dude, wake up. I'm missing something. All right, just hit enter and see what I'm missing while it's running. Yeah, it's waiting. That's good. All right, so unfortunately, you rinse, lather, you repeat. You're submitting to this giant monster in the sky. Package of the Uber. Yep. Submit the jar, yep, sure. So what I'm waiting for is this magic kind of that says, hey, I'm uploading that jar. So, it's going to be about 10 more seconds here. And there it goes. So it got pushed off and running. So great. My topology's running somewhere. It's running where? In this big cluster somewhere. Where is that cluster? Well, for me, it's on a little virtual box instance that's running a product called Hortonworks Dataflow that has Storm and some other technology. Again, trying not to have a Hortonworks commercial. So it's running this, I'm going to go to this tool called Mbari to find my GUI, the old school GUI, to Storm. So you could go to Storm and, follow the directions and run a storm cluster without someone like Hortonworks in there. You can easily do that. Encourage you to do that too. If you want to do it a fast way, go to Hortonworks and download one of the sandboxes. It has a bunch of other stuff, but it would definitely get storm up and running. So what do you see here? This is that old school kind of Craigslist system, the basic UI. It tells you all kinds of details about what's running, everything, but really, what it really matters, what I'm really looking for is, hey, what are the running topologies? I've got one. It's called the word count solution. It's been up a whole 31 seconds as of a few minutes ago. See how long it's been up now. Minute 7, right? One worker, one VM. It's got 6 executors. Well, those are kind of those instances. One, there's a spout, there's a bolt, there's 2 more bolts, and there's some other guys to do some other work. So it's kind of housekeeping. So we'll drill into that guy, word count topology. So that, remember, that word is what I meant, that if you do run Storm, you probably want to think about that word, be a little bit more global, because there's only one list of running topologies. So I'm in the topology, again, lots of details. It's all about windowing. You know, it's going to run forever, so what's the last couple minutes, couple hours, day, what's it been since the dawn of time, how many things have come and gone. So what he's telling me here, and those numbers probably should have been a little closer together, but they'll catch themselves up. He's how many things have admitted? So he's admitted 400 sentences. That can't be right. I don't think I have it set that slow, but okay. I have a list of spouts, a list of bolts. There's my generator, there's my splitter, there's my counter. Those executors are how many instances of every one of those. I'm not going to change the parallelization. I'm just going to show it running. And you can drill into each one of these. I'm just going to jump to the pinch and say, let's look at the counter. I would rather run this in a very distributed world that all you're going to see is that counter's information, but I have one VM, so all the logs are all slammed together. Imagine that. So you're going to actually see the output from all 3 different things at once, and I need to, because that thing's a little finicky. So this is just kind of a runtime log. Obviously, I put these nasty splats in there, but if we look really close, let me see if I can find word count, splitter, sentence. Maybe my sentence guy didn't, we typed the sentence guy, right? We didn't add a sys out count. Yeah, fair enough. Let's see if I can find one there. I was trying to get a handle just to look at just the sentence, but nonetheless, what you're kind of seeing is those outputs like, hey, the guy that we wrote splitter now, the good news is we put it in debug mode, which can be changed at runtime, and all that information is there as well. So he's telling you very clearly that splitter, bolt emitted, something called white, Snow White and the 7 dwarfs, those kinds of things, what you see here, here, and here. And then our counter, hopefully, if we saw Snow White and the 7 dwarfs, then sooner than later we'll find our word counter that notice, hey, there was Snow White and the 7 dwarfs. Hey, there's a sentence guy. Okay, good. There's a new sentence got admitted. So I'm commingling things like crazy, and that's okay. That might be in practice. And it is what it is. I just want to make sure you got that these things are running rough out there in the La La Land. I think that's mainly what I wanted to show in there. This thing, one more thing is kind of nice about, at the topology level, they do have a kind of recently, again, it's very boring looking on the console, I get it, but they did introduce this little visualization tool not too long ago, which is kind of nice. It's a relative tool. Blue is spouts, greens are bolts. The thickness is how many events, so obviously the sentence generators emitting this many, and the word generators emitting that many. In fact, the counter, even though we emitted something, we technically emitted something, and by doing that, we can get a nice info log message showing what it's emitting, but no one really cared about it, so it actually didn't send it anywhere, it just kind of squashed it. And then ultimately, there's a command line tool to start, stop, deactivate, pause, quiesce, reparalyze, respread, all those kinds of controls. And then there's some rough kind of versions of that from the GUI here to kind of shut things down. So I'll keep it running in the background here.
What is rebalance?
Rebalance is it's a kind of a double whammy. One could be that what if my cluster had 10 machines today and then I had 10 machines tomorrow? Storm inherently does not try to, because it's very elastic, right? We can be elastic. Storm will never, ever do anything for you. Storm will tell you what's going on and you make decisions. I need more or less. So rebalancer is a way to say 2 things. Maybe I have more hardware, so spread it out a little differently, or I want to change those parallelizations. So when I rebalance, I could say, hey, splitter, I want 12 of those. I can just declare the name of the runtime component, Don't tell me if it goes up or down. Just tell me what number you want it to be, and I'll adjust it and take care of it for you. All right, so I think we're close to the end, so if anyone wants to hang around, I want to punch to the end and tell you a couple more things, and then I'll pause for the night. I'm a little more than an hour, but
Mike.
hopefully not too far off. And the microphone. All right, so there is a lot more to Storm than I promise. There's a lot more to Storm than you're seeing. I just want to give you a little taste of it, like a good user group meeting. See if it's something that's of interest to you. You know, do you have a use case where something like this would make sense? There's a ton more additional features that I'm going to mention. I'll just hit on one or two of the big ones. For sure, that's a pain in the butt, what I just did. You know, you want to run it in your IDE, so there is a way to, you know, run everything local, put breakpoints, all that kind of silly stuff. But this is like all these kind of big data solutions I work in. The reality is you run at scale, and you run on 20 or 40 or 100 machines, so your mind doesn't think that way, so you dumb it down to one instance, but tools are there to let you do that. Pretty easy to do. Another big thing is this notion of reliable operations that we started the conversation on, and we're not going to finish until maybe later today or later than today. But everything is in Storm is based off the fact that there's a different type of component, spouts versus bolts. Anything that he raises, you know, it may, you know, a sentence came along and it created 6 words, and those 6 words did something. They kind of call that a tuple tree, and what we're looking for is, did all of that finish? Did anything go wrong, or did anything ever time out? And if so, then the framework's going to catch it and go back and initiate the spout and say, hey, we need to replay this. Now, this is not something you turn on willy-nilly. It's easy to turn on. You just do one thing and it's going to be there. This is kind of expensive. You start saying 10 million transactions a second, every transaction creates 5 more transactions. It takes some resources to do all this stuff, but it's inherently there. It's called reliable operations, very easy to turn on, and it's very sophisticated. You can shell out at any point. You can say, hey, everything from D down doesn't matter, so let it fail, and that kind of stuff. And those timeouts by default are 30 seconds. So we're thinking and that's like a high water mark. If something took more than 30 seconds from when a spout emitted it and it was done, something's really going wrong. So you could change that number, but I would imagine we're talking about a couple seconds at most ever. Okay, so there's all kinds of stuff around that reliable operations that we just don't have time to get into. I mentioned instead of writing the Java code, there's some other ways to create those topologies. In fact, there is that thing called the Streaming Analytics Manager I told you about that's actually building a visual control. So it's pretty nice stuff. Hasn't quite made it to Apache incubation stage, is working on it. This is a Java user group, and Storm is written in, anyone know? No. We write our topologies and spouts and bolts in Java, but the framework's actually written in Clojure. And I didn't get the exact answer on this one, but Alibaba, if you remember from the beginning, is one of the biggest users of Storm, and Alibaba rewrote Storm in Java. They call it JStorm, and they submitted JStorm back to Storm, and the Storm PMC, if you're familiar with the Apache terminology, the project management committee, has thought long and hard and has made kind of a directional statement that they are going to take that code drop and add security, add all the things that are missing, and at some point in the future, create a Java line with the intention of eventually silencing the Clojure line. Why? Not because they dislike Clojure, they are Clojure bigots, but it's open source, it's Apache, and it's all about this meritocracy. It's all about this way to bring people in, and not a lot of people write Clojure, believe it or not, so they are looking for ways for other people to contribute directly to the framework and participate. So it's kind of weird for almost a 10-year-old framework to actually change technology, and there's not a lot written out there, so it's directional, not JIRA ticket number 29. Okay, but that said, Java is the language of choice, but we can use any language here. It has a Java shim, and it talks it via standard in, standard out, wraps it in JSON. Kind of ugly. I would say do it in Java and have 1 or 2 bolts that make sense in Python or some other language if you have some interesting logic that you just can't surface some other way. I mentioned there's a other framework out there called Spark Streaming. Anyone heard of Spark Streaming? Spark Streaming. 3 people. Okay. Then I won't tell you my Spark Streaming joke. So we do have a concept called micro-batching. That just means, what if I want to do either an amount of time or a number of events and clump them together and then process those in chunks? We can do that. And that's kind of the gateway drug to getting exactly once processing via some more work that you have to do. But that Trident world, if you look at this API, it actually looks a lot like what Spark Streaming does. It looks almost identical in many ways. It's interesting, and it's been there a good while. Very fault tolerant, isolated, has lots of integrations. And in fact, these integrations are the demo that I wanted to do. And when I get home tonight, I will reply and give you a link to the slides, give you a link to that YouTube video, leave you a link to a GitHub project to see these simple code examples. And I have one that looks like this. I got a topology that's running, pulls some stuff off Kafka. It's like a server logs, trim down simple server logs, pull them into Kafka, kind of parse them out. We're only looking for warnings and errors. I parse it a little bit, filter it, and then I decide, what do I want to do with them? I want to put them in HBase and maybe even raise them in another message Kafka topic. So if you want to see some integrations, I have really this code, and it does this. Hey, is this message a warning or error? The rest is just taking bolts and spouts off the shelf, properly configuring them to find these remote systems, and then run. So, and I think that's a strong suite, a strong point of Storm as well, those integrations, and then just let you focus on the most important things. I think that's it. All right, so it's a little more clunky than I was hoping for, but it's a good dry run for me. I just put this together last week, so hopefully it was good.